So imagine we have a football is punted into the air. The football is initially traveling at a speed of 72 feet per second and is punted from a height of 4 feet. The height of the football in feet is modeled by the function f of t is equal to negative 16t squared plus 72t plus 4, where t is measured in seconds. So this is the setup. Now we're going to answer some different questions regarding this model. First, we're going to find f of 1, including units, and explain what it means in the context of the problem. So first, find f of 1 including units. So 1 is a time in seconds because t is measured in seconds. It's the input. And we're going to plug it into our model. So we're going to have f of 1 is equal to negative 16 times 1 squared plus 72 times 1 plus 4. That's negative 16 plus 72 plus 4. And that is equal to positive 60. Now the output of our function, f of t, is the height in feet. So we have 60 feet is f of 1, including units. But now explain what we just found in the context of the problem. So we would say, after 1 second, the ball is at a height of 60 feet. So this question is to get us to understand what this function does. We input time in seconds, we get out the height in feet at that time. Now we want to find the maximum height of the ball, and when does the maximum height occur? So this function tells us the height at given times. And this function is a quadratic function because we see the t squared. And because the leading coefficient is negative, it's a downward facing parabola. So a rough sketch of this model here is going to be a parabola facing downward, something like this. And what we want to know is the maximum height of the ball. So what this question is really asking me to find mathematically is what we call the vertex of the parabola. Now we can go ahead and do this in two ways. We can complete the square on this quadratic, or we can use what is called the vertex formula. So that's what I'm going to use. I'm going to use the vertex formula. So the vertex formula in general says we're going to do negative b over 2a, and then we're going to plug that into the function. So in this case, that's going to be f of negative b over 2a. Now, the value of a is the value in front of t squared. The value of b is the value in front of t, and c is the constant. So we're going to go ahead and find negative b over 2a. So that value, it's a time. So t is going to be negative 72 over 2 times negative 16. So we have negative b over 2a. So that's going to be negative 72 over negative 32. And that's going to be 9 over 4 as an improper fraction. As a decimal, that's 2.25. So 2.25 seconds. So that's the input of the vertex. And we want to know what's the maximum height of the ball. So we actually answered the second part of this question. When does the maximum height occur? So at 2.25 seconds, that's when the maximum height occurs. To find the maximum height, I'm going to plug this into f. So I want f of 2.25. And if we substitute that in, and if we use a calculator to compute this value, we end up with exactly 85 feet. So when we plug in a time, we get out a height in feet. So this height up here is going to be 85 feet. So the answer to the first part of the question, find the maximum height of the ball, That's going to be 85 feet. When does the maximum height occur? That's after 2.25 seconds. Now we're being asked to find when the ball hits the ground. Round your answer to the hundredths place. So here's our informal model of the football that's being punted into the air. And if I want to know when the football hits the ground, that's when the height of the ball is equal to 0. So if a ball is on the ground, its height is equal to 0. Well, the height of the football was called f of t. So what we're being asked to do in this part is we're being asked to solve when does f of t equal 0, or when does this quadratic negative 16t squared plus 72t plus 4, when does this equal 0? Now to set a quadratic equal to 0, if it factors, then ideally we would factor it, but in this case we're going to apply the quadratic formula to find the 0 since it doesn't factor. Now, as a reminder, the quadratic formula says to find the solutions, in this case t, it's going to be equal to negative b, so negative 72, plus or minus the square root of the entire quantity b squared, 72 squared, minus 4a, the value of a is negative 16, times c, which is 4, all over 2a, which is negative 16. And then we would simplify what's underneath the square root, and we end up with this 5,440, which turns out there is a factor in there of 64, and the square root of 64 is 8. So this does simplify to 8 radical 85. The denominator is negative 32. So after some of this arithmetic here, we end up with our two solutions. When we solve a quadratic equation, we can get up to two solutions, and we get negative 0.05 or 4.55 seconds. So why do we get two answers? Are both of them the answer? Well, we get two answers because we're solving when the quadratic is equal to 0. So what are the two x-intercepts, or in this case, t-intercepts? Well, our initial height of the football being kicked was at a height of 4 feet. And so if I just think about the parabola as a graph, I know that this entire parabola would keep going and would intersect the x-axis somewhere else. So it looks like that, t-axis intersection location is going to be negative 0.5. But that doesn't apply to our problem. We wouldn't have a graph over here on the left side because t, or time, would be negative, and that doesn't really make sense. So that's why we don't graph that portion in our model. So we're going to ignore that value or anything to the left of that vertical axis there. So negative 0.05 doesn't apply, and especially because the question asks, when does the ball hit the ground? So if my football is being punted, it's going to hit the ground at that second time, which is approximately 4.55 seconds.